Hi, it's Sam. In the first video of this series of looking at the MC objects and making our additive synth, we started making the skeleton of our additive synthesizer by creating the harmonic message with the MC sig to generate the frequency values that are being sent to our MC cycle object that then generates the sine waves that give us our additive synth with all of its harmonics. To clean this patch up a little bit, I added a send and receive for the velocity values, and I kind of moved things over a little bit. I also wanted to point out that to be more precise with what's going on with the harmonic message, this is going to be the fundamental frequency, which I'm getting out of the left outlet, then times the channel number, multiplied by 1, which is the multiplier after harmonic. So in this case, I just said 1, so it's being multiplied by 1, which is not changing it. So here, the full message meaning is that we're doing harmonics, multiply each one by 1, so not changing them, and the fundamental frequency is going to be whatever M to F is sending out. Okay, hopefully that is clear. So now I want to go over how we're going to do the pitch modulation. And you could use all sorts of different kinds of waves, like triangle, saw, whatever you want. But I'm just going to go over a basic implementation using a sine wave. So let's start off by making a subpatcher so that this doesn't get too messy. And I'm going to call this, actually, I'm just going to call it pitch mod. Okay, now I've got a fresh patch. Let's have an inlet. Maybe it's a little bit bigger. Let's have an inlet for deciding if this, let's see, the depth amount, and this will be between 0 and 1, and also for the frequency, which I'll put between, like, I don't know, 0.01 and 20 or something like that. Okay. I also want to add a feature of offsetting the phase of each of the different channels of this LFO. So I will also make this here like phase spread, which will just be 0 or 1. Okay, so with this in mind, let's start off by making MC cycle. And we're going to have 32 channels. Each of, need 32. Okay, now we've got 32 channels. So each of these are going to potentially have a different, once we have the phase spread, each of these will have like a different value. Otherwise, we wouldn't really need 32 channels. But if we want to use it in a way where each of these 32 signals has a different offset, then we are going to need 32. So let's just keep it like that. And let's first set up what we need to do if we want to do that kind of phase spread. So let's make a select object, which will let us decide what message should go to the MC cycle. And the first will just be 0. We're going to be dealing with the phase, which is the right inlet here. So first will be 0, which will tell it that the phase spread is off, so all the phases should just be 0. They're all aligned again. But if it's 1, we want to spread out the phases. And there's different ways that we could set this. So I'm going to use spread inclusive, which means that both values are going to be inclusive, which means they'll include both of them. So it's going to be 0 to, I'll do like 0.99, because 0 and 1 would be the same as far as phase is concerned. 1 is the same as 0. And this will spread the phases between the values of 0 and 0.99, depending on the channel. It'll spread them evenly, or as evenly as it can. Okay, and that's probably all I think we have to do here so that we can spread the phases. So that's easy enough. To set the frequency, we can just have a floating point box number outside of the second inlet. and that'll come into the first inlet of MC cycle, which will set the frequency. But now we need to set what the different values are that are coming out of cycle, because right now it's going -1 to 1. So what I want to do for the output, let's see, right now it's doing -1 to 1. What I want is 0.5 to 2, which would be as if we're doing like a octave. Oops, I can spell, I swear. Octave down, or octave lower to octave higher. Okay. So we need to scale this accordingly, because right now it is not giving us the values that we want. And I think that we actually could, isn't there like a MC, is there an MC scale? Yeah, there is an MC scale. But, you know, that's not fun. Why would we do that? We could instead just use some math stuff. So let's do that. We're going to use MC multiplication, and let's plug this out of here. And we're going to need to scale this based on the depth. And part of the reason we would still have to kind of do some figuring out with scale anyways, because if I want to include depth, then I have to change the scale according to how much the depth is. And so this way is fine. I'm just going to kind of give you how to do it anyways, so it won't be too bad. So into the right inlet, I'm going to multiply whatever the current value is of our depth by 0.75. And that'll scale the signal accordingly. And then I'm going to send it to addition. So here we're scaling the signal as we need to, and then here we're offsetting it. So it's kind of these two kind of combinations. We're scaling it because we need a larger range than we have right now. Actually, I'm sorry, we need a smaller range, because right now the range is -1 to 1, which is a range, a total of 2. And we actually want 1.5 to be our range. And then we also need to offset it, because the starting point should be 0.5, not -1. So we're going to have to do the scale and offset operation to the signal. So here, we need to add 1, and we also need to multiply. I swear, I'm usually good at typing, but it's harder to do when I'm recording like this. Okay. So now we are scaling our scale value and our offset value depending on the depth. And this is really nice, because now we can add or subtract some depth to it so that the effect is either kind of gentle or subtle, or it's much more intense. Because without the depth value, it's kind of just on or off, and we can only change how fast it is with the frequency, but we can't change the depth or how much it's actually affecting the signal. So this is a nice way of setting it up that I would recommend when you're working with this kind of modulation. It's a very nice way of getting more control. And with this, I'm pretty sure we are all set. So we just need to use an outlet to send out the signal. Okay, so that's that. Let's go back here, connect our signal, and then we're going to need to have another toggle. And this is for the phase spread. And then we also need the frequency and the depth. And I'm going to make a couple floating box here. And I'm going to go into the minimum and maximum just because I don't want to put any weird values. 0.01 to 20 for frequency, and I will do 0 to 1 for the depth. And let's see if there there any mistakes? Okay, now let's turn on, I should probably make sure that these values are kind of initialized, blah, blah, blah. Okay. Now let's turn on pitch modulation. At a depth of 0, nothing should happen because I'm not applying any modulation. Okay, so at 0, so if you don't hear anything, I sometimes get confused with this. If depth is 0, then nothing's happening to the signal. So let's turn it up to, let's just do a full blast at 1, and let's just keep this at 1 as well. Great. Now I'm going to put it on polyphonic so I can just... So you'll notice that when depth is a lower value, you're not hearing as much of the effect. Now, the whole point of including the 32 channels was so we could do the spread of the phase, and let's see if that's working correctly. Try to tell me that's not incredible. That's incredible. What a sound. That's so fun. Okay, so that seems to be working now, and nothing else is breaking either, so that's a good sign. And I think I'll stop there for right now. We've implemented the pitch modulation, and that's quite a feat, I think, so good work. Like always, please let me know if you need any clarifications and if any questions. And next time, let's take a look at adding in the amplitude modulation portion of the synth. Thanks for watching, and class is dismissed.